All right, thank you guys for joining this session. So, in the beginning, working together as developers and operators has been very, very tough. There's been this one phrase, it works on my machine. I don't know about why it's not working on production. And sometimes it makes the different team have some minor misunderstanding where there need not be, because the common objective for the company is to push out the stuff out there to the users and then, make the money. Now, these separate teams have different KPIs for their own assessment, but pursuing a common goal, which is making money for the company. Now, the disparity between development environment and production environment has mostly been an issue. Before now, it's always the case. I would use a startup. I would basically make my session revolve around startups. It's not like this does not apply to an enterprise company, but it's more advantageous. Its use case is far more beneficial to a startup where there are lean resources. So this disparity amongst developers and operators actually makes work a bit frustrating until the DevOps Agile methodology came in. Now, most people would always say DevOps is just another buzzword, but frankly, DevOps is awesome. It's an agile software development methodology that has proven itself in many established companies, as in startup companies too. So what is DevOps? DevOps is the efficient development, deployment, and operation of high-quality modern software. What this simply means is we do not anymore wait for months or years before we deploy our applications to the user. We are kind of doing that within a very reasonable time. As in, when I mean reasonable based on the project, based on how the project is. If it's some manageable project, you could push out to the users in a month or two. Unlike when the waterfall approach was being used, which takes months and sometimes even years before some release is done. And again, when that happens, there usually comes this conflict. Now, Vagrant came to the rescue in the DevOps space, in the DevOps movement. Vagrant is an awesome tool for making things work, and everybody is happy. The developers are excited, the operators are satisfied. Nobody is now making it look like the other team is not working and the other team is working. Now, what is Vagrant? Vagrant is a tool for building virtual machines. Simply put, Vagrant is a tool for orchestrating a development environment that is in parity with your production environment. So every operating system, Windows, OS, Ubuntu Linux distro, Fedora Linux distro, or CentOS Linux distro have this unique implementation that has subtle nuances within their operating system. An example is you can run a command to display your IP address in a Windows environment using IP config, right? But you wouldn't use the same syntax to display your IP addresses in a Linux environment. Now, if a developer, this is just a way of making the picture clear. If a developer happens to write his code in a Windows environment, it is certain to break in an Ubuntu environment because Ubuntu will not understand that command. Now, Vagrant came to the rescue. With Vagrant, you orchestrate a development environment that is both what developers are using for their development and both what the operators are using to the public. And it's quite a cool one. The Vagrant is written in Ruby. I don't write Ruby, and I didn't even need to learn Ruby. So I will be showing a snippet. Here's a snippet of Vagrant code. A quick explanation of what this snippet is doing is it is provisioning an Ubuntu operating system, as in an Ubuntu virtual machine. Excuse me. Then using a specific SSH key. It's that choice, just to assume that the security measures are put in place. You could choose not to use an SSH key that is secure. You just use a Vagrant own defined SSH key. So I'm provisioning my own SSH key and naming the machine, giving the machine a unique name for identification, configuring the machine using Ansible and Shell, that's Bash, and then specifying some resources that I need, some specific resources that I'm interested in. Say I want a 1 gig RAM, or I want two virtual CPUs for the provisioned machine. Now, so let's take a look at a quick demo. I have done those things, and I'm not looking at running them all over again because that would be taxing. Okay. So here is a demo of provisioning an Ubuntu OS using Vagrant. So just a quick workflow of what a particular team could start up with. So the operator can just simply write the Vagrant file, push it up to GitHub, and from there, developers can pull down, and with just a Vagrant up, hoping or in the understanding that this system have already been installed with Vagrant and whatever hypervisor they choose, whether VirtualBox or the other flavors of hypervisor. And voila, they get an operating system to work with. There you go. Now, you want to see if that's true. I already have this. That's the provisioned Vagrant.
Hey, Samuel.
Oh, sorry.
We're still seeing your slides.
Somebody's mentioned. Okay, you're still seeing my slides? Oh, forgive me. Let me share the screen. Oh, sorry. Sorry. Okay, you can see the screen now, right?
Yeah, that's
my apologies.
Thank you so much.
Good. So like I said, this is a quick workflow. Is the operators just write a background file after a general understanding of the operating system they want to use for the production, or the operating system they will be developing on top, whether Windows, thank you, whether Windows or Ubuntu. So Here we are provisioning an Ubuntu OS for our project. Now, once the operator, writes the Vagrant file, believing that the developers have installed their preferred hypervisor, I'm using VirtualBox, by the way, here, and a Vagrant software with just a Vagrant up. With just a Vagrant up, the system is provisioned, and developers can start doing their work without having the need to write on their own personal systems or having the same issue that has plagued our domain for a long time. And here you find this is our development environment as it were locally. So you can see this is a private IP address. So the developer can keep doing their work, seeing what it is like that they are doing. Now, this only happens in the developer system. If, say, developer A wants to see what is happening on developer B system, all they need to do is do a git fetch and then update their code base, as in locally, and what the other developer is doing or what the other developer has committed to GitHub gets displayed on their own local system, right? So now we've showcased how you could use Vagrant to provision an operating system. The next tool, which is one powerful tool that has also come to the rescue for the DevOps engineer, is Terraform. Now, I love Terraform both for simplicity and for speed. Fine, I do hear some of my colleagues back then will tell you that, oh, Ansible is a cool one too. Well, I also use Ansible. I use Ansible very well, and I think I will be showing a little demo with Ansible. Ansible is not the focus of this talk, but Ansible will be used just to showcase how we bootstrap our production environment. Now, the gains of Terraform as a tool is speed, basically. Terraform is written in Go, while Ansible is written in Python, and it's quite slow for me. I like things fast. I don't know, but it's quite slow for me, so I went for Terraform. Another good side of Terraform as a tool is that you could use Terraform to orchestrate your environment, your resources on multiple clouds, and even on-prems. Now, in on-prem environments, you can provision resources on OpenStack, VMware using Terraform, which is very awesome. So one tool doing a dozen things for me. Now, here we'll be showing how you can even use Terraform to provision your GitHub projects. You know, make life easy. You don't need to just keep clicking console up and down to like provision a minor code base. Sorry, provision a minor project repository. With just a few lines of code, the project repository is made ready there. The URL for the project repository is delivered to the developers on their Slack channels. Life made easy. The developer can just pull down the repository, get to work without wasting time. We don't love wasting time. It's really, really cost. What do I say? It's not cool. So now, that's my own case for why I prefer Terraform. I could also choose to use Ansible, but personally, I would not want to use Ansible based on my own personal preference. So I don't want it to sound like I'm becoming an ardent of Terraform, but trust me, once you start using Terraform, you might become a diehard fan of Terraform too, just like myself. So now, here is what a Terraform snippet looks like. You can see how beautiful it looks. And what the snippet is just showcasing is I want to provision some resources on AWS Cloud. So I tell Terraform, the provider I want to provision resources on. I tell Terraform the operating system I'm interested in. Go get the AMI of the operating system from Amazon Linux environment. Then again, just for security reasons or for security purposes, provision an SSH key to make sure my environment is secured. So let's do a little demo again for Terraform. And so here you go. So like I said, this is the code for provisioning a repository. And what you see after running this, to do that, I just need to run, first I'll cd in into the repository, which in my case is repo GitHub. So that's it. Cd in into the repository, and with just the one line command, Terraform apply, that stuff is spinned up for me, and there you go, this is it. I'll try and see how I make this available for people to go learn with. So I have my provision project code base, I have the cloud code base, I have the application code base. This is where our application will be residing. This is where our cloud architecture will be residing. This is where our configuration files will be residing. Sorry. So this is what I pointed earlier. These are the things that the last operation provision for me. So let's go back to the code base now. And here you can see the URL is all displayed. So I can hand the developer, whichever developer, this URL, they can clone it. Sorry, you cannot clone this. This is on a private repository. So I don't know, don't even think about it, but I'll make sure it's available for everyone. Now, once this is done, I move on to provisioning my resources. So just same thing. What we'll be provisioning is just what we saw earlier in the snippet: a server, the SSH key, some security groups, a load balancer, an auto-scaling group system, and also set a scaling policy for the auto-scaling group. So that's that. Okay, I think I have just 8 minutes. Also set a scaling policy for the auto-scaling group. And with this, I toggle between both my development environment, which is in this developer's system, and my production environment. So whatever the developer is doing is kind of, I would use the word kind of because after all this, we still need to feed these things into Jenkins, if that's your own automation tool, to run these processes automatically for us as a pipeline, so that the most recent commits from developers can be built and then made ready for maybe the staging environment before we fully deploy to the production environment. And I think I would want to cut it short here because I think my time is almost up. So that's for this session. Any question, please?
Hey, Samuel, that was awesome. We do have 5 minutes up until the next talk. So if anybody wants to ask a question for Samuel, please use the Q&A section on the webinar, and yeah. So you have a question there, Samuel. Anonymous attendee, guessing not real name, says, do you use Terraform in combination with Ansible as well?
Yes, exactly. Yes, so it's just for lack of time, I would have shown you how. There is, if you followed on from the beginning of the session, in my display of the code base, there is a provision folder there. The provision folder there is where I wrote the Ansible YAML files, the Ansible configuration file. It is with this Ansible that we both bootstrapped our local development environment using Vagrant, and it's still with this Ansible provision file that we will be configuring our cloud production environment and to get everything in shape. Process for that, because again, Ansible is a little slow. A better process for that is to throw Ansible into Packer, and Packer will build an AMI, so your spinning up your production instances spin up faster. With Ansible and Packer, you will orchestrate a server template that will make your production instances easy to bootstrap. So I think it's one other HashiCorp tool I strongly recommend to DevOps guys. So yes, to answer your question, yes, I do use Terraform with Ansible.
I really like that Packer-based approach as well, Samuel. It's a kind of a really elegant way to build those images, and then it makes your deployment so much quicker with Terraform when you're just pushing out an AMI as opposed to having to bake in any software.
Exactly.